All right, so this looks like a related rate type problem here. So we know the altitude, which of course is going to be the height of the triangle here. And we're just going to call this H. And then we're going to call this entire base just B. And of course, we know for a triangle, the area is 1/2 base times height. So the altitude is increasing. This is a rate, so that tells me dH dt is equal to 3.5. And dA dt is 2.5. Find the rate at which the base is changing. So I always like to write out what variable am I actually solving for. So dB dt is what I want here. So my final answer better have a dB dt in it here. So there's a lot of derivatives here, so that means I need to take the derivative of this problem. So if I take the derivative of this, I would have dA dt is equal to 1/2 product rule here, so it's first, times the derivative of the second, dH dt, plus the second variable h times dB dt. Well, we know dA dt is 2.5 is equal to 1/2. The base, we don't actually know the base, so I'll worry about that here in a second. We do know dH dt is 2.5. Plus the height, they did tell me the altitude, which I didn't write, but the altitude is 9.5. And I also didn't write that A is equal to 86. So the height is 9.5 times the actual variable I want, dB dt. So I need to find this B. And I'm also going to use this 86, which we haven't touched yet. So we know the area of this triangle is 86. Well, that's equal to 1/2. They say the height is going to be 9.5. Like that. So in order to solve for B, I'm going to multiply both sides by 2. So that would be 172 is equal to 9.5b. Then, of course, we can divide by 9.5. And when we do that, we end up with 18.105. 26. I always like to have a lot of extra decimals there and then round later as needed here. So now that I have that number, I can plug that in. So again, I'm going to multiply by 2 and get rid of this 1/2. So that means 5 is equal to B, which is 18.10526 times 2.5 plus 9.5 dB dt. I'm going to multiply that out. So that's going to be 18.10526 times 2.5. That's 45.26315. Plus 9.5 dB dt. And then solve for dB dt. Subtract off the 45 point ... to both sides. So if I do that, I get negative 40.26315 is equal to 9.5 dB dt, and then divide by 9.5. So then dB dt is equal to negative 4.238, and my unit would be centimeters per minute, since that is one directional. Area is square units because it's base times height, so that means the base and the height rates would just be one dimensional, centimeters, and it's a rate, so it's per minute in this case. And this makes sense because area is increasing, but also the altitude is increasing at a rate, and it makes sense that they both shouldn't be increasing at a rate there. So it makes sense that the dB dt is negative in that case. Hopefully this helps out for the related rates. Feel free to post more or reach out to me if you want to set up some tutoring sessions for calculus.